The Voyager 1 spacecraft from NASA, the farthest traveling spacecraft ever launched, continues its awe-inspiring journey through the cosmos for nearly 50 years. Voyager 1 has been sending back crucial information from the farthest reaches of the universe, making significant progress toward our understanding of the cosmos. However, recent messages sent by this extraordinary spacecraft have shown baffling indications that have left the entire space community in a state of awe and bewilderment. These signals have sparked debates about whether they are the result of a technical glitch or if they could be indicative of something significantly more unusual, such as extraterrestrial activity. Join us as we delve deeper into the mystery surrounding these remarkable transmissions and discover what may be lurking in space's darkest corners, humanity's fascination with the mysteries. Beyond our planet has been a driving force in space exploration. Since its beginning, this unquenchable curiosity led to the historic launch of missions like Voyager 1 and Voyager 2, which were among space's most ambitious endeavors of their time. The launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977, marked the start of a new era in space exploration. 14 days later, on September 5th, Voyager 1 followed, setting the stage for a first-of-its-kind journey. These twin spacecraft, each weighing approximately 720 kilograms roughly, equivalent to a small car, were launched during a rare alignment of the outer planets that had a significant impact on their paths and the results of the mission. Throughout their remarkable odyssey, these spacecraft traveled in divergent directions and at varying speeds. A pivotal moment occurred on December 15, 1977, when Voyager 1 overtook its twin due to differences in their paths. Since then, Voyager 1 has emerged as a vital asset, providing invaluable information that has revolutionized our comprehension of the universe and its myriad phenomena. Before we dive into the most recent and astonishing findings from Voyager 1, which have attracted the interest of the entire space community, let's revisit some of its most remarkable achievements. During its Jovian imaging in 1978, Voyager 1 was about 265 million km from Earth. By January 1979, it had embarked on an exceptional 100-hour mission to capture a mesmerizing time-lapse film of Jupiter's rotation. This series of 3,750 images offered unprecedented views of Jupiter's dynamic atmosphere and its complex features. The spacecraft's findings included the discovery of 2 small rings around Jupiter and previously unknown moons, greatly expanding our knowledge of the gas, the giant's intricate system, to ensure the spacecraft's safe passage and avoid potential collisions. With Titan, one of Saturn's moons, corrective maneuvers were executed. After the successful Saturn mission, researchers chose to conclude the planetary mission of both Voyager 1 and Voyager 2. However, the spacecraft were sent on a new trajectory, beyond the confines of our solar system at an incredible rate of 325 million km per year. In January 1990, Voyager 1 marked the beginning of its interstellar mission, continuing its celestial journey. During this period, Voyager 1 made significant discoveries, including the identification of 4 additional moons of Saturn, including Enceladus and Rhea, and captured some of the most iconic images ever taken of our solar system. On February 14, 1990, Voyager 1, positioned approximately 6 billion kilometers from the Sun, set out on an excursion known as the Family Portrait, capturing breathtaking photographs of the solar system's planets. This collection of 60 images added to Voyager 1's impressive portfolio of 670 photos. Taken during its encounter with Neptune, Voyager 2 also achieved remarkable milestones during its mission. As it approached Neptune, it recorded wind speeds exceeding 1,300 meters per second, the highest speed ever recorded in our solar system. This accomplishment provided invaluable insights into Neptune's distant atmosphere and its largest moon, Triton. Triton's surface temperature drops to a frigid -391 degrees Fahrenheit, making it one of the coldest places in our solar system. Triton also displayed unique characteristics, like ice volcanoes that erupted nitrogen gas and propelled frozen particles 5 kilometers into its hazy atmosphere. These extraordinary findings have deepened our understanding of the diverse and complex nature of celestial objects in our outermost solar system. The Voyager spacecraft delivered profound and transformative outcomes. Voyager 1 and Voyager 2 revealed that Jupiter and Saturn's moons, once thought to be heavily scarred and inactive, are actually brimming with geological activity. Voyager 2 in particular achieved several historic milestones, such as becoming the first spacecraft to fly past Uranus and Neptune, and remains the only spacecraft to do so. NASA made use of a variety of methods to improve the FTR operational duration of these ambitious spacecraft, including shutting down non-essential heaters and energy-saving systems. The mission is expected to conclude in 2030, marking a proud moment and a touch of melancholy for the scientists and engineers who have dedicated themselves to this extraordinary endeavor. The design of Voyager 1 and Voyager 2 was an engineering marvel. The stability of these spacecraft was designed into platforms rotating at a rate more than 15 times slower than a clock's hour hand. This design choice reduced visual blurring as the spacecraft traversed enormous space. Even before reaching the outer planets, spacecraft started sending pictures of Jupiter, revealing its swirling clouds and iconic features. The Great Red Spot, a massive storm on Jupiter, captivated crowds at NASA's Jet Propulsion Laboratory. But the finding of active volcanoes on Jupiter's moon, Io, garnered the most attention. The spacecraft's instruments detected abnormal signals from Io that were confirmed by unique images showing soaring plumes of volcanic ash and a surface scarred by eruptions. One of Io's most prominent volcanoes erupted with a force 10 times greater than Mount St. Helens, covering an area nearly the size of France. While the spacecraft carried on their travels, their cameras were eventually turned off to conserve power and memory before they ventured into interstellar space. Notably, the images they captured did not include Mercury and Mars for various reasons. Besides the Voyager probes, NASA has launched other important spacecraft like Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Voyager 1 surpassed Pioneer 10, becoming the farthest spacecraft from Earth. Despite the absence of other planets to observe, Voyager 1 carried on its own journey for 14 more years before crossing into the interstellar medium. On August 25, 2012, the Voyager missions were made possible through various innovative techniques, with gravity assist maneuvers proving exceptionally brilliant. These maneuvers were critical for propelling the spacecraft to their faraway destinations and collecting valuable data. The spacecraft relied not only on their own propulsion systems, but also on gravity assists to achieve their goals. Visualize the two fearless spacecraft gracefully navigating through our local planetary system. Utilizing the gravitational pull of planets to propel themselves, this celestial dance allowed them to conserve fuel and achieve the necessary speeds to visit different locations. A gravity assist maneuver involves providing spacecraft with a small amount of a planet's energy as it passes by with extreme precision. For example, as Voyager 1 approached Jupiter, the planet's gravitational pull was used to accelerate the spacecraft. Significant attraction due to gravity increased the speed of the spacecraft. Its precision-achieving velocity was essential, for any departure from the correct speed or angle could have led to a disastrous outcome. The daunting accuracy required was successfully achieved. The creative forces behind these projects successfully carried out these gravitational assists, sending the spacecraft on a remarkable journey multiple times. These assists made the grand tour possible. Voyager 2 was seen in celestial maneuvers utilizing the assistance of gravity from Jupiter and Saturn to reach Uranus and Neptune. The Voyager missions' success owes much to these gravity aids, as we consider the amazing journey of these revolutionary spacecraft and the wealth of knowledge they have provided. We eagerly await more information regarding the examination of Voyager 1's most recent anomalies. Both Voyager 1 and Voyager 2 continue their missions beyond earthly bounds, and their accomplishments include exploring Jupiter and its moons, Saturn and its moons, Uranus, and Neptune. Voyager 1's time-lapse images showcase 10 rotations of Jupiter, including the vivid discovery of new moons and a small ring. These findings have greatly enhanced our understanding of Jupiter's complex system. Additionally, Voyager 1 uncovered four additional moons of Saturn Mimas. Enceladus, Tethys, and Rhiannon captured remarkable photographs of Saturn and its rings, offering fresh perspectives on Saturn's intricate system. The spacecraft made history by visiting Uranus and Neptune, supplying valuable details about their atmospheres and moons. It's enhancing our comprehension of the outermost reaches of our solar system. After completing their planetary missions, Voyager 1 and Voyager 2 ventured into interstellar space, gathering data on the cosmic environment. This ongoing investigation continues to increase our understanding of the universe beyond our solar system as we await more information about Voyager 1's latest signals and the repercussions they could have for our comprehension of the universe. The amazing journey taken by these spacecraft continues to inspire enthusiasm for science and space among admirers. Their groundbreaking achievements keep pushing the boundaries of human knowledge and exploration, highlighting the boundless potential of space discovery. The Voyager missions have provided us with a treasure chest of data regarding our solar system and beyond. The spacecraft's data and iconic images have also been the bearers of a golden record, a unique artifact designed to communicate the story of our world to extraterrestrials. This record contains sounds and images chosen to portray life and culture. From around the world, it includes greetings in 55 different languages, music from various cultures, and a selection of natural sounds like thunder and whale songs. This message in a bottle, so to speak, reflects the hope that one day, if intelligent life exists elsewhere, they might locate it and comprehend it. It's offering a glimpse into humanity. Voyager 1 and Voyager 2 were equipped with scientific instruments that have revolutionized our knowledge. These instruments included magnetometers, plasma wave detectors, cosmic ray detectors, and imaging systems, each supplying important information about space phenomena. For instance, the magnetometers provided new perspectives on the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing the complex relationships among these planets and their surrounding environments. The plasma wave detectors helped us comprehend the nature of the solar wind and its interaction with planetary atmospheres and magnospheres. One of the most remarkable aspects of the Voyager missions is their ability to measure the heliosphere boundary, a vast bubble of solar particles and magnetic fields that encloses our solar system. As Voyager 1 approached the edge of this boundary, it detected a sudden change from the solar wind to the interstellar medium. This data was significant in shaping our knowledge of the heliosphere's structure and its role in shielding Earth from cosmic radiation. The data gathered by the spacecraft provided evidence of an identifiable boundary where the solar wind becomes slower and denser, known as the termination shock. Beyond this lies the heliosheath, an area where the solar wind interacts with the interstellar medium, creating a complex and dynamic environment. Voyager 2's travels have been equally groundbreaking. Following its successful flybys of Jupiter, Saturn, Uranus, and Neptune, it has continued to provide valuable data on the outer reaches of our solar system. Voyager 2's observations of Uranus were particularly notable for revealing its unique magnetic field, which is significantly tilted compared to the planet's rotation axis. This discovery challenged existing models of planetary magnetism and prompted additional research into the magnetic environments of other celestial bodies. In addition to their scientific contributions, the Voyager missions have had a profound impact on public interest in space exploration. The stunning images of distant planets and their moons, combined with the personal stories of the spacecraft's journey, have captured the imagination of people around the world. From the images of Saturn's rings to the detailed views of Jupiter's moons, especially Io's volcanic activity, these visuals have inspired countless individuals and have been featured in educational materials, popular media, and documentaries. The missions have fostered awe and curiosity about the universe, emphasizing the significance of exploration and the search for knowledge. The engineering and logistical feats achieved by the Voyager missions are also noteworthy. The spacecraft were designed to operate in extreme conditions far from Earth, temperatures dropping below -200 degrees Celsius, They rely on radioisotope thermoelectric generators, RTGs, for power, which provide a constant energy source despite their vast distance. From the Sun, the engineers who designed and built these spacecraft faced numerous challenges, including ensuring that the instruments would remain functional for decades and that communication could be maintained over such vast distances. The information provided by the Voyagers has also affected our perception of the larger cosmic environment. The spacecraft have mapped the distribution of cosmic rays and revealed information about the density and composition of interstellar dust. This information is critical for understanding the conditions in the space between stars and for preparing future missions that may investigate additional star systems. As the Voyagers continue their journey into interstellar space, their legacy is strengthened not only by the data they have already provided, but also by the inspiration they offer for future investigation. The missions pave the way for new technologies and methodologies in space science and have set a precedent for ambitious long-term space missions. They demonstrate the possibilities of human ingenuity and the value of perseverance in the face of daunting challenges. Looking forward, the Voyager missions have sparked a generation of spacecraft and missions. The goal of future investigations is to build on the Voyager's success and travel even farther into space. These upcoming missions will continue to push the boundaries of our knowledge and will benefit from the foundations laid by the Voyager spacecraft. In conclusion, the Voyager missions represent one of humanity's greatest achievements in space: exploration. Their contributions to science, their role in advancing our knowledge about the solar system and beyond, and their impact on public imagination highlight the significance of continued exploration and curiosity. As both Voyager 1 and Voyager 2 travel further into the cosmos, they remain symbols of human aspiration and the never-ending search for knowledge.